The universe is not what you think. Black holes might have existed before stars, shaping the cosmos in ways we barely understand. But what if entire clouds of gas collapsed straight into black holes, skipping star formation altogether? What if the first great anchors of galaxies were never stars at all? Today, we dive into the untold origins of black holes and the radical theories that challenge everything we thought we knew about the birth of the universe. Deep in the silent void of space, massive clouds of gas and dust drift like cosmic ghosts. They're called nebulae, and they're supposed to be the birthplaces of stars. Normally, these clouds hang out for millions of years, chillin' in a delicate balance. Gravity wants to crush them inward, but internal pressure says, "Not today, buddy." But all it takes is a little cosmic push, a nearby supernova explosion, a rogue passing star, or just a critical buildup of mass, and suddenly the whole thing collapses in on itself, kick-starting the wild and messy process of star formation. Gravity takes over, pulling everything tighter, heating it up, and setting the stage for a glowing ball of nuclear fire, a newborn star. Gravity is the sculptor of stars, pulling matter inward, causing the nebula to shrink, heat up, and spin. As the collapsing cloud condenses, it forms a dense core known as a protostar. This stage is tumultuous, marked by violent turbulence as material spirals inward, generating friction and increasing temperature. For a protostar to transition into a true star, it must reach a critical threshold: nuclear fusion. As gravity squeezes the core tighter, temperatures soar to millions of degrees, forcing hydrogen atoms to collide with such intensity that they fuse into helium. This process releases an extraordinary amount of energy, creating an outward pressure that counteracts the inward pull of gravity. When this balance is reached, a star is born. The energy radiates outward, pushing away any remaining dust and gas, signaling the end of its formation phase. Stars do not form in isolation. Their birth is deeply tied to the structure of galaxies. Most star formation occurs in the spiral arms of galaxies, where dense clouds of gas are compressed by the galaxy's rotation and interactions with other star-forming regions. The Milky Way, for instance, hosts sprawling stellar nurseries, such as the Orion Nebula, where young hot stars illuminate the surrounding gas with their brilliance. The birth of new stars plays a crucial role in shaping a galaxy, enriching it with heavy elements forged through fusion, seeding the cosmos with the building blocks of planets and, eventually, life. However, not all newborn stars will enjoy a long, stable existence. The most massive stars, burning at extraordinarily high temperatures, live fast and die young. When their nuclear fuel is exhausted, gravity reclaims its dominance, causing the core to collapse catastrophically. In the most extreme cases, this collapse leads to the formation of a black hole, an object so dense that not even light can escape its gravitational grasp. Black holes can range in size from a few solar masses to the behemoths that lurk at the centers of galaxies, where supermassive black holes, millions or even billions of times the mass of the Sun, exert their influence over entire star systems. One of the most profound questions in astrophysics is whether some nebulae collapse directly into black holes without forming stars at all. In the early universe, when conditions were different and gas clouds were more pristine, this may have been possible. Some theories suggest that massive collapsing clouds in the primordial cosmos could have skipped the stellar phase entirely, giving rise to the first black holes. These objects might have later merged and grown into the supermassive black holes that now anchor galaxies. Black holes and star formation share a deep connection beyond their origins. The energy released by massive stars as they go supernova can trigger the collapse of nearby nebulae, sparking the birth of new stars. At the same time, the powerful radiation and winds from black holes, especially those in active galactic nuclei, can both stimulate and suppress star formation. This cosmic interplay shapes galaxies over billions of years, determining how and where new stars will emerge. Thus, the story of stellar formation and nebula collapse is not just about stars. It is about the evolution of galaxies, the birth of black holes, and the intricate web of cosmic events that link them all together. From the gentle stirring of a nebula to the brilliant blaze of fusion, and finally, in some cases, to the inescapable abyss of a black hole, the life cycle of stars is a testament to the dynamic and ever-changing nature of the universe. I'll leave you to discuss in the comments. Could the first black holes have formed before stars even existed? You can support us by subscribing if you haven't already. Take care of yourselves, take care of your loved ones, and I'll catch you soon in another video.